Okay, we are going to look at our second part of this example where we will remember controlling the weight of jumbo ravioli. In our food processing plant, we had sample size of 4, we had 15 trials, and we calculated for n equals 4 an X bar of 35.72 ounces and an average R of 2.02. Now, we knew that for the UCL, the upper control limit, we needed to have the constant A2. So here in our table, we find the constant A2. And the way this works is we're looking for our n equals 4. So A2 for this example will be 0.729. And for the range control charts, we needed to have D3 and D4. And likewise, for n equals 4, we have D3 is equal to 0, and D4 is equal to 22.82. So we can use these constants then, as I've got written down here. A2, 0.729, D3 is 0, and D4 is 2.82. So to do the control limits, we have them UCL X bar plus A2 times the range bar gives us 37.19 as our upper control limit for the X bar. The center line is just X bar, and the lower control limit is X bar minus A2 times the range bar, 34.25. And for the range control limits, we have then D3. I can write this, so this is D3, this is D4, E2, and this one is D3 times range bar, and we get then 4.61 for the upper control limit of the range and the lower control limit of 0. So again, we've used the data that we have. We don't have 25 data points, we only have 15, but we've used what we've had. We used the correct constants for the control limit calculations, and we've come up with the numbers. And again, these represent these so-called 3 sigma control limits. So as we learned, when we are measuring ravioli weights, we expect that 99.7 of the weights will fall within these control limits. And if one doesn't, it means our process is out of control. Something exceptional has happened. So let's use these now and plot them in our graphs. And this is very rough, not very well presented, I have to say, considering I did it. But we have here our upper control limit for our X bar graph, our lower control limit here, and our center line. And here are connected by the dots, then by the lines, our X values. Here for the range chart, the R chart, we have an upper control limit, lower control limit is 0, and a center line, and our range values. So you've done the analysis, you've done the data, very nice. What does this tell you? So the first thing, you start normally with a range chart because you need the range bar to calculate the X bar chart limits, but this is not in control. And likewise here, this is also not in control. There's only one point out, but out of 15 points, we have one point that is falling outside of these 3 sigma limits. So what we would do then, we would remove the point, and generally you would remove it from both. Don't, strictly speaking, have to, but you would remove this point from both charts. What's that, the 4th point? Want to this point as well. You would remove this point. You would start with the range. You would remove the points and recalculate. Most likely then you would see this go down slightly, the UCL and the LCL, and then you would perform the process again until you get 2 charts that have all the points in control, And if you don't have very many data points at that point, you may recommend that you take more data and recalculate. So I hope that gives you an example, and yeah, we can look at some more of those a little bit later. Okay, thank you very much.